What I'm going to show you in this video is a little bit about negative bases and what that does once the number is put into standard form, or in other words, once we start using the exponent to perform the operation. So the first example right here says 4 to the second power, and hopefully you're already familiar with that. That would just mean 4 times 4, and 4 times 4 becomes 16. This next one though, you can see the base is now negative, and it's in parentheses, which means you're going to do negative 4 as a base 2 times. So there'll be negative 4 times negative 4. And then from there, since it's a negative times a negative, that ends up getting you the same result that you got before, which is positive 16. The next one here, there's no parentheses around this 4. And so the way I try to always relate it is, imagine this is an order of operations problem. And we've got some number over here. I'll just say 20. So 20 minus 4 squared. So if that's the case, then we would just do 20 minus 4 times 4, which is 16. And so that ends up equaling 4. You notice how this 16 made the number smaller, though. And in reality, what we did was just 4 times 4. So I'm going to erase the 20 now. But hopefully you keep this in mind, that this is still just 4 times 4 with a minus sign in front of it. So now if I'm going to write this out in expanded form or factored form, I keep that minus sign there, that negative sign, which I'm just going to read it as the opposite of 4 squared. So 4 squared, we saw above, is 4 times 4, which is 16. So this will be equal to the opposite of 16. Next one for you here, 3 cubed. That would just be the same thing as 3 times 3 times 3. And that, of course, is going to equal 27. Now this one will be the same result, except it's negative. And so we've got a negative times a negative times a negative again. You know, the negative times a negative is going to equal a positive. And then a positive times this last negative over here has to equal a negative. So this will be a negative 27 when it's all said and done. And the reason that this one's negative and the last one was positive, hopefully you can pick up on this, we have an even exponent. So anytime you have an even amount of numbers, it means you're going to end up with a positive. A negative times a negative is a positive. But when you do an odd exponent, a negative times a negative is a positive, times a negative is a negative. And then this last one, again, it's 3 times 3 times 3, and we're just taking the opposite of whatever answer we get. So this will be 9 times 3, which is 27. And again, you're taking the opposite, so it'll equal negative 27.